organic compound is extracted from its natural sources or from the synthesized form in the laboratory, it is essential to be purified it. The liquids having a different boiling points will be vaporized at a different temperature. The vapors are cooled and the liquids are formed or collected separately. This method is based on the difference in the tendency of a substance to distribute or the partition between the stationary and the mobile phase. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with a unit called Organic Chemistry, some basic principles and techniques. Under this unit, we have studied about the nomenclature of organic compound which are containing functional group as well as the bifunctional compound, and how the IUPAC system has given the rules for naming this functional group containing organic compound. Suppose if two functional group is there, how to name the organic compound also we have learned. Today, let us move on to the most important topic of this unit, that is methods of purification of organic compound. So, under this topic, we are going to understand how sublimation will be done, what is crystallization, distillation and chromatography and its type we are going to understand in this session. Okay. Let us see how the methods will be followed in order to prepare or in order to purify the given organic compound. Once the organic compound is extracted from its natural sources or from the synthesized form in the laboratory, it is essential to be purified it. That is why we will go with the purification processes. The various methods which will be used for purification of organic compound based upon its nature. Based on the nature, whether it is from the natural sources or it is chemically synthesized, based on that process, we are going to purify the given organic compound by using some of the common techniques, and the techniques are sublimation, crystallization, distillation, differential extraction and chromatography. Okay, let us understand what is mean by sublimation. Okay, sublimation is a method that used to separate sublimable compounds from non-sublimable compound. So imagine you have ice cubes with you. If you are going with the sublimation, in the ice cube, if any impurities will be there, that will be converted into, or if any impurities which is there, it has to be removed from that organic compound. That is why you are going to melt your ice cube into its liquid form. So that is the simplest example where the sublimable compounds are going to be separated out from the non-sublimable compounds. Clear? Next is crystallization. This is a method based on the difference in their solubility of the compound and impurities with a suitable solvent. So what does it mean? So here we are going to select the organic compound and it is mainly dissolved in suitable solvent. When you dissolve it, the organic compound will dissolve in your solvent, whereas the impurities will become insoluble. Based on this principle, we are going to separate the impurities from the given organic compound. Okay, the impure compound will be dissolved in a solvent in which it can be, it is sparingly soluble at the room temperature, but appreciably soluble at higher temperature. The solution is concentrated to get nearly a saturated solution. On cooling, the pure compound which crystallizes out and removed from the filtration, and the filtrate that contain the impurities and the small quantities of the compound. This is how they'll do the crystallization. I'll repeat once again. Remember, Here we are going to select the organic compound and we are going to dissolve that organic compound in a suitable solvent. As a result of that, the given organic compound can easily dissolve in the given organic compound will be soluble in suitable solvent, whereas the impurities are become sparingly soluble or completely it will become insoluble also. After heating this mixture, we are going to cool it and we are going to filtrate it. The filtrate you got it, that itself is a impurities and you are going to get the organic compound in very small quantity, and the process which we call it as what? Crystallization. And the next method is distillation. It is an important method just to separate the volatile compounds from non-volatile compound. Here we need to understand what is mean by volatile or what is mean by non-volatile. Volatile means any compounds which can easily get evaporated. For example, all of you know about the petrol, correct? So the petrol is a liquid and if you expose to the air, it can easily get evaporated. Such compounds we say it is volatile. If the compounds do not easily get vaporized, we say it is non-volatile. So this principle is mainly based upon the difference in their volatile compounds from the non-volatile compound, and the liquids having a sufficient differences in their boiling point. So the liquid must have a difference in their boiling point, and one liquid should be evaporated easily, whereas another one should be non-volatile in nature. Then only we can select this method to separate the impurities from the given organic compound. Hence the process which we call it as what? Distillation. Okay. The liquids having a different boiling points will be vaporized at a different temperature. The vapors are cooled and the liquids are formed or collected separately. Here you can take that. Here, this is an entire setup for the distillation, which is having a stand as well as with a round bottom flask which has been kept on the heating chamber, and it has been connected with a long tube which has been having a thermometer just to check the temperature, and also it has been connected with the distillation chamber having a condenser, and also we have a sink. Then this condenser will have a water outlet, and also the liquid substances will be collected by using a separate conical flask. I'll read out with the example how they'll do with the distillation process just to separate the volatile from the non-volatile compound. The chloroform and aniline, if you take it as a mixture, okay? Imagine you have chloroform and you have a aniline, okay? These two are the liquids you have taken in the round bottom flask and you have started heating. At a particular temperature, what will happen? At a particular temperature range, one of the liquids can easily get evaporated. When it get evaporated, it will collect it in the condensing chamber and it will be cooled back and it is collected at a separate conical flask. Like this, based upon the differences in their volatile and non-volatile nature and based upon the differences in their boiling point, we can able to separate two liquids which is having the impurities. This is how, we will do the separation of the impurities from the given organic compound by selecting distillation processes. Next, we have chromatography. Let us see what is chromatography. What are the different types of chromatography is there? Let us understand now. The techniques of chromatography is mainly based upon the difference in their rate at which the components of the mixtures will be moved through the porous medium. So, it is the rate at which the components in the given mixture can easily move through the porous medium. Then only we can decide that whether it is adsorption chromatography or it is a partition chromatography. So, it is called as what? Stationary phase, and under the influence some of the solvent or the gas, it is movable, hence it is known as what? Mobile phase. Based on the principle as I explained, we have two chromatography techniques. One is adsorption chromatography, other one is partition chromatography. Let us see with the adsorption chromatography. Okay. It is mainly based upon the fact that different compounds will be absorbed on the adsorbent to the different degrees. When the mobile phase is allowed to move over the stationary phase, the components of the mixtures will be moved by varying in its difference over the stationary phase because of the different adsorption tendency. So, this is an apparatus for the adsorption chromatography. So, here you have taken the solvent and you have taken the mixture of A plus B plus C, and this is the stationary phase. And why it is known as stationary phase? Because it does not get changed. Okay. Look at the diagram and understand. Here, when you started running this entire mixture with the solvent and also with the stationary phase, when it started moving, this mixture will be get separated from the A. Okay, A. Then it will be you are moving down the stationary phase. As we move down the stationary phase, the mixture is containing the component A and B and C get adsorbed at a different tendency. So, based upon the rate at which each component get adsorbed on that column, we are going to analyze it, and what is the rate of it, the rate at which each component get adsorbed, measure that rate, and we will record the values, and we will tell that this is actually the adsorption chromatography of the given organic compound. Like this, that entire process will be done for the adsorption chromatography. Next, we have column chromatography. Okay, here you can see that a suitable adsorbent like alumina and silica and fluorous earth has been packed in the column in a burette like long tube. So, this is a burette like a long tube. In that, the sample will be mixed with a suitable adsorbent like alumina or it may be silica. Then it is acting like a stationary phase, and the mixtures will be separated by dissolving it in a suitable solvent. The solution will be poured on the top of the column of the adsorbent, and the component at which is get adsorbed strongly and absorbed at the top, and the other component with the decreasing order of their absorbability are held up to the different zone down the column with the different bands. Here you can see that we have loaded the sample, correct? So, this is our stationary phase. So, here the sample is loaded along with the suitable adsorbent. Here I can take alumina or I can go with the silica also. So, this is, I call it as what? Sample, which I have loaded from the top, and I have a stationary phase. Now, I allow the stationary phase to move on it. What will happen? Some of the compound, or if the mixture is containing more adsorbing capacity, it will get absorbed first. Okay, due to the stronger interaction, it will get absorbed first, whereas the mixture is containing a component which have a weaker interaction, it will comes later in the column. Like this, the component A as well as the component B will be separated from the entire column, and hence it is known as what? Column chromatography. So, remember, in the chromatography, we are going to work it with the same principle, that is, each component in the mixtures which is going to be adsorbed with a different rate. Okay. Based on that principle, we are going to separate the impurities from the given organic compound. This is how, they'll purify the given organic compound from the impurities. Next, we have one more technique in the chromatography, that is thin layer chromatography. What does mean by thin layer and how the techniques will be done? Let us understand now. This method involves the separation of the mixture of the substances over the thin layer of adsorbent coated with a glass plate, and the solution of the mixture is separated, is applied as a small spot. After drying, the glass plate is placed in an closed chamber containing eluent. As the eluent raises up the plate, the component of the mixture is moving up along with the eluent with the different distances depending upon their degree of adsorption and separation processes. So this is the overall setup of the thin layer chromatography. This is a glass plate which has been coated with a thin paper. Okay. So here at particular spot, okay, like this. Okay. Imagine this is your entire thin sheet which has been which we have already placed to the glass plate. So here this is a region where we have already spotted the given organic compound. Okay, imagine this is a spot where you are already spotted the given organic compound. Now you have placed this entire glass plate inside this whole chamber and you have kept the solvent. What will happen? Because this glass plate is consists of a thin sheet, the solvent will be raises up. As it is raising up, it will also carries your mixture which is containing a different impurities or with a component, correct? So that is why you are going to get the red spot with a 2 cm, purple spot with a 6 cm, blue spot with the 8 cm, and finally you got the solvent outside. This is how just by moving the solvent, towards the upward direction, your entire mixtures which is also going to be moved up and get separated with each component. This is how just by taking the sample in very small quantity, that is in the drop wise, okay, in only one drop if you take it, you can purify each component in that mixtures by using what? Thin layer chromatography. Okay. Next we have retardation of factor, which we also call it as what? RF factor. It is obtained by a formula known as a distance moved by the substances from the baseline divided by a distance moved by the solvent from the baseline. So you are going to take the mixture. How does it move from the baseline to the upward? Whereas your solvent, how does it move from the baseline to the upward? The distances you must know that. If you put that value, you will come to know that how to calculate with the RF value also. Next, finally, we have what? Partition chromatography. This method is based on the difference in the tendency of a substance to distribute or the partition between the stationary and the mobile phase. Why it is known as stationary phase? As I told you, it will be as such. It will not move at all. Why it is known as mobile phase? Because it will be movable. Hence, it is known as mobile phase. The paper chromatography is a type of partition chromatography in which mixture can be separated. It is applied in the form of drop on the paper. This paper is suspended in a suitable solvent or in the mixture of solvent, and solvent will be raised up by capillary action, and the paper selectively retains a different component according to their different partition of the phases. This is how we can understand that what is mean by partition chromatography also. Okay. Remember, the best example for the partition chromatography is a paper chromatography itself. Okay, where you are going to imagine this is a paper. Okay, you have a thin sheet of paper where you are going to spot or where you are going to put a spot which is your organic compound. Okay, organic compound. Now, you are going to place this entire thin sheet in a given solvent with a suitable solvent. Okay. Then the solvent will be raised up and keep this spot to move with a different tendency. As it is moving up, it shows the different colors and shows that different component will be separated out. Okay, this is an example for the partition chromatography. Hope you all understood with the method of purification. So all the methods of purification, it is very, very important. First one is sublimation, distillation, then sublimation, distillation, then chromatography. In chromatography, thin layer chromatography and paper chromatography you have, and adsorption chromatography also it is there, and column chromatography you need to be practice it. Okay. In the next class, we are going to understand with the qualitative as well as with the quantitative aspects of the organic compound. So hope you all understood with this session. I'll come back with the next part of this unit. Till that, take care and be safe. Thank you.